In this lesson, we will cover questions from Unit 2, Section 2.5, using the sine and cosine ratios to calculate lengths. Question 1. What is the length of the hypotenuse to the nearest tenth of an inch? So we're going to look at what we're given here in our triangle. We have 27 degrees. So from there, we're going to label our triangle. Our opposite will be 12.5. Adjacent, we don't know, and the hypotenuse, we don't know. So we're asked to find the length of the hypotenuse. We have to use opposite and our adjacent side, or our hypotenuse side. So that will give us the sine ratio. So it'll be sine of 27, which equals 12.5 divided by our hypotenuse. So I'm just going to label that x so that we know we have to find that. If you want, you can put 1 underneath sine 27, and we're going to multiply both sides by x. So we have x sine 27, which equals 12.5. We're going to divide both sides by sine 27 in order to isolate the x variable. So x will equal 12.5 divided by sine 27. And the answer to the nearest tenth of an inch will be 27.5. So our answer here will be D. Question 2. A guy wire is attached to a tower, so that will be the hypotenuse, at a point that is 2.4 meters above the ground. The angle of inclination of the wire is 62 degrees. What is the length of the wire to the nearest tenth of a meter? So we have our theta, which is 62 degrees. Opposite will be 6.4 meters. Hypotenuse we don't know, but that is the guy wire that we need to find. And we do not need to use the adjacent side. So again, we're going to use sine 62 degrees, which will equal 6.4 divided by x. So you put 1 underneath. We're going to multiply both sides by x. So we have x sine 62 degrees, which equals 6.4. We need to isolate x. We're going to divide by sine 62 on both sides. And we will say x equals 6.4 divided by sine 62. And to the nearest tenth of a meter, we will have an answer of 7.2 meters.